Hello there. We're going to go over a few recursive problems in this video. This is a bit of a divergence from some of the other topics that we've been covering. I think in some ways this is easier, some ways this is harder, depending on how you look at things, but hopefully this video will give you a few ideas of how to set up some recursive functions. So, sort of the first one here, write a recursive function to sum the digits a positive integer without using any loops. So sum the digits, and what I mean here is if I have the number 123, the digits of that are 1, 2, and 3. So the answer I'm looking for is 6. 1 plus 2 plus 3. So how do we do this? Well, let's figure it out. Okay, so let's open a new notebook. This will be exercise 1. All right, let's include our usual friends. I guess I should put the comment up here. Okay, so anytime that you're working with a recursive function, the first thing you need to figure out is how are you going to make sure it stops. So before you worry too much about how to actually tackle the problem, what you should think about is what is the simplest example of some input for your function where you don't need to do recursion at all. And in this case, to sum the digits of a positive integer, we can think about there are a few cases where you don't have to really do much of any work at all to be able to do it. In the case of, for instance, the number is less than 10. If the number is less than 10, or I guess between 0 and 9 inclusive, then the answer is easy. The sum of the digits is the digit. The sum of the digits of 7 is 7. There's not too much work to be done there. So before we go off worrying too much about recursion, we should first start thinking about our base case. I don't think it gave us a name for this, so we're just going to call this int sum digits. It's going to take an integer. Okay, and so always, 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 when you write a recursive function, you should think about the base case, recursive step, verify that the input, the parameter usually, is decreasing. If you don't have these things, you have no guarantee that your recursive code will work. The base case is necessary to make sure that we're actually going to stop at some point and not go on forever. Similarly, the last step is important for helping to make sure that we actually get closer to this base case and don't just keep recurring over and over and over and over. So the base case here is if our integer is less than 10, now we know that the integer is positive. If it was negative, we'd have a lot more stuff to worry about, but it says here it's a positive integer, so okay, we'll assume it is. In that case, we just return the integer. Boom, done, easy. Okay, so that's all well and good. Our code works for 0 to 9, but it doesn't work too well for anything bigger than that. So what do we do? Well, here's what we look at. If we think about, some examples here, before we go coding, let's, think about what this might look like. Suppose we have 1, 2, 3, right? This is clearly bigger than 10, so we have to figure out how to break this down. Well, the sum of the digits is 1 plus 2 plus 3, or the sum of the digits of 12 plus 3. This works out to be the same thing, right? The reason that this is really helpful, though, is we can get the 3 on its own using modulo. If we take our 123, for instance, and modulo 10, we get the 3. So that's kind of handy, right? We can just take the 3 and then add that to the sum of whatever digits are left. So here is what we're going to do. We are going to and I guess we could do this in one line, but just to space everything out nicely, we're going to say, so int the last digit is my integer modulo 10. So now I have the last digit, and what I want to return is the last digit plus the sum of the remaining digits. Now, here's the part you have to think about is what are the, and this is our recursive step. What are the remaining digits? Well, in the case of 1, 2, 3, it's 12. But how do we get that 12? And if you think about it for a little bit, you might come to the conclusion that modulo 10 gives us the 3, and if we want to get everything but the 3, we can just divide by 10. Remember, this is integer division, so if we divide 123 by 10, we get 12. which are the digits we want to worry about. So all of this code should give us exactly what we're looking for. We want to verify that the parameter is decreasing, because as it gets below 10, we know that we're going to eventually stop. Whoa, the power flickered in here. Fortunately, I'm on a laptop, so it's okay. I'm not going to shut off my desktop or anything like that. The storm outside is looking particularly nasty. I guess if anybody's super curious, just for fun, you can see over here. Maybe you can see. I can't quite tell. But it's blowing a bit of a storm out there. So hopefully I don't lose internet. I guess if I lose internet, that's a bit of a problem because I won't be able to code too well. Worst case, maybe I'll have to grab an IDE of something, but hopefully everything should stay intact. Anyway, now that I've got my my recursive step, integer divided by 10 is clearly decreasing. I'm dividing by 10 every time. And that means it's getting closer to the number 0 to 9, one of the two. Now, to make sure it works, let's just try it out. What's the sum of the digits of 1, 2, 3? 6. Sounds about right. About the sum of the digits of 1, 2, 3, 4, 5. Is that 15? Check. And you can test some more if you feel like it. But that's it. Not too complicated of an example, but it's nice to have broken down all the pieces that are necessary. You need to have your base case. This is just a little bit of a step to help us figure out the problem. You need to have your recursive step where you're making a recursive call, and you need to verify that it is decreasing. If I just pass integer without dividing by 10, this will never stop, and that's no good. So that's it, exercise 1. How about number 2? Well, write a recursive function called repeat that takes a string s and an int t, should put string in full letters, that prints out the string s total number of times without using any loops. Okay, so let's give that a shot. Your notebook. Example 2. Okay, so might not even need. Oh no, I do because I need string. No loops. We're gonna do this recursively. Okay, so our function is called repeat. It's gonna print some stuff, but it's not gonna return anything. So this is a void function called repeat. Should probably have a lowercase r for the sake of good style. Take a string s and int t, and it's going to print out s t number of times. So first of all, again, going back to the idea, base case, recursive step, make sure we're getting smaller. And here our base case is if t is 0, then we're done. Otherwise, now we need to actually print stuff. So we want to print out s, and then we want to repeat, but this time we want to repeat one fewer time, which means our string is still the same, but we're going to print it out t minus 1 times after this. So let's say that t was 4. I want to print it out 4 times. The first time I go through, 4 is not 0, so we keep going. We print it out once, and then we'll repeat it 3 times. We'll print it out once, then repeat it 2 times. Repeat it out once, repeat it 1 time. Print it out once, repeat it 0 times, which says to not print anything. And so now if I repeat, well, I guess I should declare a string variable. So here's my string, hello. And I'll do repeat my string, say 5 times. There it is, 5 of them. No loops. I do this all recursively, which is the niceness of this. I don't have to write all these clunky fors. The trick, though, is that you have to figure out how to do this properly recursively. So base case here is just this. So we got base case, recursive step, t is decreasing. So it's important also to note that what's decreasing here does matter. If our string was shrinking, that's not helping us get to our base case. We need to make sure that this variable is actually getting closer to here. And assuming t is a positive number, I'll reach that at some point. Repeat it negative times, and of course this will fail, but that's okay. All right, last exercise. Write a recursive function that performs a linear search. You may not use any loops. Okay, so linear search. In other words, if I have an array, find something in it. Now we're used to, iterate through each element, see if it's there. If not done, great. But we're going to do this with recursion. So we need a third notebook. Does linear search, can't use any loops. Not a problem. So we're going to, in this case, I haven't set a lot of parameters for this question because there's a lot of different ways that you can think of how a linear search might work. What we're going to go with is this. We're going to have a Boolean function called search. It's going to take as parameters a integer array and the size and the target, which is what we're looking for. And what I want to do is return true if it is in the loop, if it's in the array, and false if it's not. Now, and here's how I'm going to do it. Again, base case, recursive step, check for decreasing. So the base case here is if my, well, now here's kind of where it gets tricky, right? Is, my array can't change size. I can like lie about the size of my array, but I guess that's one way to do it. Is we can pretend that the array is smaller than it actually is, and what we'll do is we'll keep checking the last element that's there until we reach the very end. So let me give a little example of what this might look like. So example. So suppose I have the array 1, 2, 3. Size is 3. Target is, let's say, 1. We're trying to find 1, right? So the first time we check 3 is not 1. That's a final element. And then we're going to recurse where size decreases to 2. On the first recursion, we are only considering the array 1, 2. And then we keep doing this until the size is 0. And at the time that the size is 0, we clearly have not found it, and so we return false. Which means if the size is 0, we are done. We didn't find it, we return false. Otherwise, it is the case that we might find it. So now we need to check if it's there. If the array at the size -1, so remember, if the array has 3 elements, size is 3, that means you want to check the last one, size -1. This is at index 2. If that is our target, return true. Great. Otherwise, we're going to return search again recursively. So this is our recursive step. Saying that you can maybe say we have sort of 2 base cases in a sense, is we found it and then we're done. But this is really what I would call the base cases. Once you have gone through everything, there's nothing left to do. You cannot shrink any smaller. You stop. And so here is us hoping that we find it, and then assuming that we haven't reached the end and we haven't found what we're looking for, we need to keep searching. To keep searching here, we still want the array. We still want the target, but our size is going to go down. And that's going to help us approach this size equals 0, which means it will stop at some point. Okay, so now if I have int array is 1, 2, 3, 4, 5, then I can do search for the array. There's 5 elements, and we'll look for a 2. Oh, what did I mess up? Oh, I forgot the square brackets. There we go. True, it's there. Is there a 6 in this array? False. Is there a 1 in this array? True, there is. All right. So, not too complex examples. I don't think we plan on doing anything too advanced with recursion in this course. I think that's better saved for some of the second-year courses you might be taking, where you learn some recursive algorithms such as merge sort. Of course, we're going to cover a few of these in the lecture as well, but these are just a few examples that you should be comfortable with. They're not too long. There's obviously not a lot of code that's written here, but what's really important that you take away is the strategy, which is base case first. Always code the base case first. Recursive step. Figure out, once you have realized it's not a simple problem, how do you break it down? and make sure that you're actually breaking it down. You're actually shrinking what's there. Because if you made this size +1 or size, it's going to go on forever, not going to be useful. All right, that's it. Thanks for watching, and I'll see you in class. Bye-bye.